Okay, lesson 1.6, solving systems of equations. So we've got two equations here, and this is a warm-up question, but it's basically what we're going to be doing here today. So we grab, I'm going to graph this one. It has a y-intercept of -3 and a slope of 1. So I apply my slope of 1 on my y-intercept of 3, and I am ready to graph. And I try to draw a straight line the best I can, and there we go. And then I like to do these if I have the opportunity to use another color. I do, because now I'm at +1, and I apply a slope of -1, and we can see, oh, look at that, a point of intersection. Is that going to be important? Oh, I think so. Oh, that scale is a little off there. That's okay. And then we draw our line, right? And if I had done this properly here, we should see that we have a point of intersection at 2, -1. So if you plugged an x equals 2 in there, you get a -1 over there because 2 minus 3 is -1. If you plug a 2 in here, you get -2 plus 1 is -1. The one point that satisfies both equations is the point of intersection and going to be the solution to the system. So we can have a couple of things happen. Two equations is called a system, all right? So we've got two equations, two variables. So if you have one variable, you only require one equation to solve it. If you have two variables, and you're looking for one solution, two variables, two equations, three variables, three equations. More on that later. The ordered pair that is a solution to both equations is the solution. So on the last example, we had 2, -1. There are three different types of solutions. You can have one, which is an ordered pair. You can have an infinite number of solutions, or you could have no solution. So as we examine those things, if we have a point of intersection, we have one solution. It's one ordered pair that is a solution to both. In this case, it looks like it's 0, 0. That's not very fun. If we have an infinite number of solutions, that means that there are an unlimited number. It means they are the same line. It's one line on top of the other. Oftentimes you can't even see it. So they graphed one here with a thin black line, and they graphed the other one with like a yellow, mustard yellow highlighter, so you can kind of see that they are on top of each other. And that means that they're exactly the same, which means they share every point, so it's an infinite number of solutions. And then the third one, no surprise, these are parallel, and we know very easy to identify. You would be talking about the same slope, but you'd also be talking about a different y-intercept. This one looks like it goes through 1, 2, 3, 4, 5.5, and has a slope of, oh, I don't know, what is the slope of these guys? It's not a very nice slope, but anyway, it's going to work. And this one goes through -2. So they have the same slope. Slope here looks to be about 2/3, I think. So this one's like y equals 2/3 x minus 2. This one's like y equals 2/3 x plus 5.5. And since the slopes are the same, they will never intersect because they are going up at the same rate. We've got a word problem here where we have new release movies and we have outdated movies. So we need to define variables. So maybe we want to say X are the new releases and Y are the old releases. So then this is your Y or your old, and this is your X or your new down here. Most of these real world problems we do in quadrant 1, so this is the origin, okay? State the equations. It says they sell new releases for $5 and outdated for $2. On Wednesday, they sold 19 total movies. That means new movies plus old movies was equal to 19. So number of movies, total number of movies. And it says that they're $5 for the new ones, $2 for the old ones, $50 total. So I'm going to have 5x, 5 times every new movie, 2 times every old movie is $50. So we're going to graph both of these now. So my first one is this one is y equals -x plus 19. That's one of them that we will graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 8. Oh my gosh, it's almost like we planned that. And then you can do this. We've got a slope of -1. These systems, I do like to plot more points because we are going to look for the point where they intersect, right? And then if I had a straight edge, I would draw this, but I guess I'll do the best I can. Let's see how well I can do. Oh, that's not terrible. Usually it's a little harder on these pads. And then this one, I'll subtract the 5x, so I get 2y is -5x plus 50, and I'll get y is -5x plus, 5/2x plus 25. Now, I don't have 25 for a y-intercept on there, but one thing I can do is I could pick a number, right? I could pick a number and I could figure out a point. We'll go back to the point slope idea. So if I picked x as, I don't know, let's pick x as 10. If I put a 10 in there, and now I can solve this. Oh, 10 is, wait a second here, 10 times -5/2. Well, that's going to be 10/2 is 5, -2, it's 10, 0. Oh, interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now -5/2, I'm going to grab a different color here just for fun. -5/2 is up 5, 3, 4, 5, left 2. And I'm going to, whoa, I thought I grabbed a different color. What's going on? What's going on? 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. Ah, and it's like, oh, you have a little bit of joy in your life. 1, 2, 3, 4, 5, when you find that point of intersection. So now I graph, and I want to be a little bit careful coming through here because we want to capture the one that makes it work. So my point of intersection is this guy. It looks like x is 4, right? 1, 2, 3, 4. And I don't have to count all the way up. I can say 4 plus what is 19? And it's 4 plus 15. So we have 4 new releases were sold, 15 old releases are sold. Okay? So that's solving by graphing. We graph them both, find their point of intersection. Sometimes it's going to be hard to find that point of intersection because they're not nice points, which means we need some other methods. Here we go. Substitution. Solving by substitution. Substitution. What you're going to do is you're going to solve one equation for a variable, and then you're going to sub into other equation. Okay? I'm going to solve the top one for x because there's no coefficients. You want to pick smartly, add the 2y over, and I know that x is equal to 2y minus 3. So now I'm going to plug, since these x's are going to be, this x right here is the same as that x right there, I can replace this. And what do? I'm going from 2 variables down to 1 variable. And now I'm ready. 6y minus 9 plus 5y equals 24. Move the 9er over there. 11y is 33. Y is 3. And now all we have to do is go right here to solve for x. Look at how wonderful that is. 2 times 3 minus 3. X is 6 minus 3. Oh my gosh, x is also 3. So my answer is an ordered pair of 3, 3. It satisfies both equations. Plug back into check. It works. Substitution here. I would maybe solve for this x or this y. I'm going to solve for that y just for fun. So I move the x's over. Y is negative x minus 2. That's going to go up here. 2x plus 2 times negative x minus 2 equals 8. 2x minus 2x minus 4 equals 8. Combine the like terms. My x's are gone. I have negative 4 equal to 8. Is negative 4 equal to 8? Absolutely not. You just can't do it, sir. Or maybe you would have added that 4 over and I had 0 equals 12. Is 0 equal to 12? It's not. Well, my x's went away. What's the deal here? If we get something that is untrue, it's no solution. And what kind of answers are no solution? Parallel lines. Substitution, when they're both equal to the same variable, you can just do this. This is a great way. It's already set up, 4x minus 2. I would go this way because negative signs, like negative people, are no fun. And I get, whoa, I was getting ahead of myself. 2 plus 2 is 4 equals x. Look at that. And then plug that up in there. Y equals 3 times 4 plus 2. Y equals 14. So I get 4 and 14. Whoops, there's another one over there, and I got to erase this. Unbelievable. Erase all ink. Okay. And then last substitution one here. Maybe I solved that for x. X equals 1 minus y. Take that 1 minus y, put it in there. 3y equals 3 times 1 minus y equals 3. 3y, whoa, equals 3? 3y plus 3 minus 3y equals 3. So now I combine my like terms. Oh, they go away. Must be no solution. Oh, I moved that 3 over there and 3 over there. 0 equals 0. Wait a second. 0 equals 0. You get something that is true. That's going to be all solutions or infinite solutions or the same line. Yay. Same line. They're one on top. Oh, look at this. Look at this. They were trying to trick us. Divide by 3, divide by 3, divide by 3. Y plus x equals 1 is the same as x plus y equals 1. It's the same equation. Oh, those silly gooses. Okay, elimination. Elimination. We are going to get the coefficients. Coefficient is the number in front of a variable to be additive inverses. So you're going to match up one set of coefficients to be additive inverses. What does it mean to be additive inverses? It means when you add them together, you get 0. Coefficients to be additive inverses. That's the technical term for positive 1, negative 1, positive 3, negative 3, positive 7, negative 7. Inverses. Okay, these ones are already set up. And then I combine to eliminate. Eliminate. Got it. So those ones go away. Negative 2y plus 3y is y equals 13. Oh my gosh, we already have y. And then you sub back up, sub in for other variable. And where do I sub? It don't matter. It don't make no difference. You get to pick. I would sub into the top one because the x is standing alone. The x stands alone. The x stands alone. Hi-ho, a cherry-o. The x stands alone. X is 30. And now you get 30 comma 13 for the ordered pair. And you can see where you're not going to graph and find that, right? So that's what. So it's the old. Why don't we just always graph? Oh, I don't know. Why don't we use substitution? Oh, I don't know. Why don't we use elimination? Oh, I don't know. We got to do a lot of different stuff there. Okay, different ways to get to different things. Sometimes you got to make them into additive inverses, which means I examine them and I have a 2 and a negative 1 and a 5 and a 3. So the fastest way to do this problem is to make this one into a negative 2. So if I multiply this one by negative 2, I get negative 2x plus 6y equals negative 14. Up here, this one stays the same because now I'm ready because I have additive inverses on the x's. You can have additive inverses on the y's. It just so happens that I got the same thing on the first two. So let's see here. These ones go away. I get 11y equals negative 11, and quickly I get y is negative 1. So where do we want to sub? You can sub into either equation. I'm probably going to take it up into that top one. I don't know why, just because I feel like that's a good place to go. 5 times negative 1 equals 3. 2x minus 5 equals 3. Add 5, add 5. 2x is 8. X is 4. So I get my ordered pair of 4, negative 1, and we're good to go. Okay, so elimination. Match them up to eliminate. Sometimes you might have to combine both of them or just one of them. I look at this one, 2 and 5. I could do negative 5 and positive 2, but make it easy on yourself. I would do this one as negative 3, and I would get negative 6x minus 3y equals 0. I'd leave this one alone. Leave Virginia alone. And now when we combine, I get negative x, those are gone, equals 2. How do I deal with a negative? Oh, I divide by negative 1. X is negative 2. It appears the top one is definitely the place to go. 2 times negative 2 plus y is 0. Negative 4 plus y is 0, y is 4. You have an ordered pair of negative 2, 4, and things are going well. Sometimes you got to put them into standard form first. What's standard form? ax plus by equals c. I would distribute this one and make it into 2x minus 6y equals 6. Great. This one, let's see. I need to bring this y over. 1/3 x plus y equals negative 4. And then I should multiply everything by 3. So I get x plus 3y is negative 12. And then I take a look up here and I'm like, well, oh, that should be a negative. Geez, I almost made my first mistake of the year. That would have been terrible. Let me get this. It's like it never happened. So I minused that y over, which means that's a minus. Okay, now it's going to be much easier to see what we need to do. So I think I'm going to go ahead and multiply this one times, well, I got a 2x there. If I multiply this by negative 2, I'll have negative 2x, I multiply there, plus 6y equals positive 24. Oh no, heavens to Betsy, what's happening here? These go away. These go away. 0 equals 30. Is 0 equal to 30? Heck no. So that ain't going to work, is it? So we go not equal to, which means these are no solution, which means they're what type of lines? These are parallel lines. They were parallel lines in disguise, and now we can see clearly. I can see clearly now. Okay, hats and shirts, hats and shirts. Let's see. 2 hats plus 2 shirts equals $44. So this is price of the hats, price of the shirts. This is 3 hats plus 1 shirt equals $30. So you can do linear combination, or you could do substitution. It doesn't matter. I don't know which one you want to do. We could solve this for s pretty easily. S equals 30 minus 3h. I just moved that over. So now I have 2h plus 2 times 30 minus 3h equals 44. 2h plus 60 minus 6h equals 44. Negative 4h equals, move that 60 over, negative 16. Hats are $4. What is this, 1972? Where do you find a hat that's $4? That ain't gonna work. So if the hats are $4, then this is 8 plus 2s equals 44. And 44 minus 8 is going to be 36. 2s is 36. Shirts are $18. It ain't gonna be that jersey, more like $118. Am I right? I'm right. All right, so in recap, you're gonna solve by graphing. You're gonna solve by substitution, and you need to read the directions carefully on the worksheet, and you're going to solve by elimination, and you can either have one solution, no solution, or infinite or all solutions, and this means they cross at one point, and this means they're parallel, and this means they're the same line. There you go. Enjoy.